Ilham, our lecturer. For our assignment presentation, we have chosen the IC 18F4550, and will be accompanying me in my presentation is me myself Mustafa Azim, my teammate Noni Lansari, Siti Khadijah, and Su Insan. Okay, for our next, for moving on for our presentation, I will pass on the presentation to Kitty.
Thank you, Mustafa Hazim. So I will present about the architecture of PIC80 for F4550. In architecture, in this subtopic, have two important things, which is the oscillator and the clocking, and the other one is memory organization. PIC 18F4550 is 8-bit with Harvard architecture. It separates code and data space and pathway. It is commonly available in 14-pin VIP, 44-pin TQF, and QFN package. As we can see here, these are some of features of PIC 18. The power by 2.5 volt anti 5.5 volt DC suppliers. So it's suitable for fairly lower application. It also has a flexible oscillator structure. Next. So here, this figure is the architecture of the IC microcontroller. For oscillator and clocking, oscillator are used for timing generation. In PIC microcontroller, consists of external oscillator like RC oscillator or crystal oscillator, where the crystal oscillator is connected between the two oscillator pins. The value of capacitor is connected to every pin that decides the mode of the operation of oscillator. In the oscillator have three mode, which is crystal mode, high speed mode, and the low power mode. In case of RC oscillator, the value of resistor and capacitor determine the clock frequency, and the range of the clock frequency is 30 kilohertz to 4 megahertz. In program memory organization, have two, which is program memory and the data memory. So here, here we can see the figure of bus program memory. Program memory is 16-bit wide access through a separate program data bus and address bus inside the PIC18. Program memory store the program and also static data in system, which is on chip and external. On chip program memory is either PROM or EEPROM. The PROM version is called OTP, which is one-time programmable. The EEPROM version is called flash memory. The maximum of the program memory is 2 mega. The program memory address 21-bit address starting at location 0000. For data memory, is often divided into two sections, which is general function register GFR or register file location, and the other one is special function register SFR. Special is specific to PIC. The location of GFR is 000 times 0F7F locations. For SFR location, 0 times 80 until 0 times FFF. It up to 1 to 8 bytes. PIC chip Depending on the PIC chip, the size of GFR and SFR are different. So I pass the present to Su Yin-san.
Alright, thank you, Katie. So after this, I'm gonna present about the input-output peripherals. So first, this is the pin diagram for the PIC 18F4550. This table shows us the input-output ports for the PIC. So based on this table, port A and port C got 7 pin, port B and port D is 8, and port A got 4 pin. The rest of the pins are designated as VDD, VSS, OSC1, OSC2, and CAR, and another set of VDD and VSS. So this is the circuit for the power supply as an input. This is a simple 5-watt DC regulator power supply system. 3-watt or 5-watt DC power supply are commonly used in embedded system. After this is reset signal. Reset circuit consists of push button and resistor connecting the reset pin MCRR U to reset the system. There are two types of reset circuits. So first is active high and another is active low. And then is the clock signal. Clock signal is used to execute microcontroller instruction and supply through external OSC pin of microcontroller. However, modern microcontroller come with both external and internal oscillator. The example of external clock source are crystal oscillator, resonator, and RC circuit. This is the example of input and output device. Embedded system that contains microprocessor or microcontroller can be directly interfaced with input and output device. So for the example of input-output device, for input can be a switch, LDR, micro switch, or pressure pad, and the potential output is LED, bulb, speaker, buzzer, motor. The classification of input-output device can divide by two. So the input device is analog input, digital input, and the output device is analog output or digital output. For the digital input, state should be in logic low and logic high in any given time. Two types of input circuit are active low circuit. The initial state is high, turn to low when the input is active. And the other type of input circuit is active high circuit. Initial state is low and turn to high when the input is active. So this is the active low and active high input circuit. The digital output, the simple digital output is LED. Connecting the LED without a resistor is likely to damage both the LED and the PIC. Two types of LED connection is sync mode or source mode. So below is the circuit for the LED circuit. The two mode is sync mode and source mode. So and then driving load with higher current or voltage. Digital output from a microcontroller is typically a low amperage signal. And for example, when you put a pin height on a microcontroller, the voltage coming from that pin is typically positive 3.3 volt or positive 5 volt. And the amperage coming from it is typically 10 milliamps or less. This is fine if you are controlling an LED whose required amperage is tiny. And most devices you don't want to control require more current than that. In order to control them, you need something in between your microcontroller and the device that can be controlled with this small voltage and amperage. High current devices are typically controlled using signals from the microcontroller through some sort of intermediate device like a relay, a transistor, or a more highly integrated device like a dedicated motor driver controller board. Okay, that's all from me. After this, I'm gonna pass to my partner, Mustafa. Thank you.
Thank you, Suyin-san. Now I will be presenting the interrupt function in PIC 18F4550. Okay, interrupt is one of the most powerful features in embedded application. Its detection is being a key being pressed or synchronizing of video output or handle the transmission and reception of data packet for a communication device. Almost all the real-time applications are implemented using interrupt. Interrupt is basically an event that requires the microcontroller to stop the normal program execution and then jump to the executed program code that related to the event that is causing the interrupt. Here we can see the figure where is the normal flow line of the task, but when the interrupt signal, it will run to the ISR signal and run the code until the end of the ISR code. It will run back to the normal code and resume its execution. For interrupt code, interrupt source, they can be divided into two groups, which is external source, which is like interruption of our external point, such as connected to port B, or internal source, or we call it timer interrupt. For interrupt register, they have INCON 2, INCON 3, PIR1, PIR2, PIE1, 2, and so IPR1 and RCON. This is what make up the register for interrupt. Okay. Now I will move on to my our analog to digital computer. Analog digital computer are binary, discrete value, but in physical world, everything is analog. Temperature, pressure, humidity, light source, or acceleration are a few examples of physical quantity that we deal with every day. Therefore, we need an ADC to translate the analog signal to digital number of the so that the microcontroller can read the process of signal. Because microcontroller cannot accept physical or analog signal, it can only receive digital signal. This is a few example of analog devices, such as light sensor, temperature sensor, touchscreen, and microphone for audio recording. For analog to digital converter, is a device, or we call it module, which convert continuous analog quantity to discrete digital value. In the ADC, they have several components, which are V reference, resolution, analog and digital conversion clock, acquisition time, and digital data output. As for ADC register, it has ADCON 1, ADCON 2, ADC result register, which for the result register, store the data from the ADC converter. Okay, now I will be passing on the presentation to Nur Nilansari.
Okay. Next is PWM. Pulse width modulation is one of the simple and most commonly used technique to produce analog voltages from digital signal. It has a wide variety of applications such as digital to analog converter, DAC, DC motor speed control, sine wave inverters, and brightness control. PWM signals are on-off signal, which is high or low. PWM output. A PWM output has a time-based period and a time that the output stay high, which is duty cycle. The frequency of the PWM is the inverse of the period, which is 1 over period. PWM register. So this is the description. PWM period. One cycle has a fixed time period called period and a varying on time called duty cycle. The speed of the motor depends on three factors, which is load, voltage, and current. So this figure is a motor driver. This is motor circuit with L293D. So next presenter is Mustafa Hazim.
One.
Okay. Thank you, Nilam, for the presentation of PWM. So now we will be moving on with our application of PIC 18F4550. There are many type of application that can be used in for PIC 18F4550, but these are the several example what is being used in. For example, it's being used in real-time clock with two alarm, which we can set up which when the alarm will go off, and we can set up the time for the real time. Next, it can also be found in a temperature sensor for room, which can detect the temperature in that room. This is the this is the circuit. And next, it can also be found in a USB mouse. Yes, it can be created in a mouse, and then it can also be found in a RF remote control, which can be programmed to control anything for our specific what is our intention of use. And then not least from us and our presentation. Thank you very much.